we're going to take a look at compound interest again, but this time we're going to flip the way we think about the question and really the equation and what it is we're actually looking for. Okay, so with compound interest and specifically present value is what we're actually going to look at today. Okay, so it's basically like I want to invest this I want to have this much money after so much time. What do I have to put in right now, right? So we've basically taken what we did in lesson 2 and we've flipped it, right? So that flip, we're actually still going to use the compound interest equation, okay? But this time we're going to, because we're flipping what it is we're looking for in the words of the question, we're going to actually just flip the equation, okay? And so you're going to recall here, okay, the equation that we used in lesson 2 with compound interest, okay? And then if we could rearrange the equation, this one, okay, to find P in this case, right? So what would have been our principal, what we would have initially invested, right? Or what our whatever it was worth at any given time. Okay, so what we're going to do here, we're just going to rearrange this equation, right? So I'm just going to take that and rearrange. Okay, and rearrange to get P. Okay, and so A is going to, I'm just going to write this again, just okay, and what you can do is actually just divide both sides by 1 plus I to the n. It's in this instance that now this whole thing is going to cancel, right? And all you're left with is the P that we're looking for, right? So P is going to equal A divided by 1 plus I to the n. Okay, that is also equal. I can rewrite this, and this is what's cool about this. So we can see some of our exponential work come in here, right? Our some of our power laws, or one specifically. I can actually write this in another way, where P is going to equal A multiplied by 1 plus I to the negative n. These are the same thing, the same equation. Okay, both of these will work. Okay, all I did here, and you'll notice, if I were to highlight what I did, the n came up to the numerator and became negative. We've seen that before, right? So generally, what happens is we substitute PV, present value, for P. Okay, where P was the principal in compound interest. When I'm looking for some amount of money after some amount of time, I can actually just make the substitute for what the principal is, right? For the present value. Okay, they're the same thing. Okay, and so we can actually rewrite this equation to be present value is going to equal A divided by 1 plus I to the power of n, which can also be equal to A multiplied 1 plus I to the negative n. Okay? Same thing. You can use either of those. Okay, and we'll see maybe we'll see specifically, depending on what kind of calculator you have, you might choose to use one over the other. Okay? So PV is going to be is the present value, okay, of the loan or the investment. Okay. A is going to be the amount. Okay, is the amount at the end of the investment. Okay. I is again the interest rate per compound period. Okay, and so by that you remember this has to be in a decimal. All right, in order to use it in the equation. Okay. You'll also remember that it's based on the wording of the question. So if I see biannually or monthly, those mean different compounding periods, right? And so we had to change the way or what our interest decimal looked like depending on what the question was saying. Okay. And then n was just the number of compounding periods. Okay. And so if that's biannually, then you're going to have 2 compounding periods every year. If I leave the money in the account for 2 years and it's compounded biannually, then I get 4 compounds. Okay. The money gets compounded 4 times. Okay. So let's take a look at a question down here. Okay. And remember, this isn't an overly difficult process, right? I gave you a procedure to kind of follow or try your best to follow, right? The first thing I always do with these questions is maybe read it, obviously, and then decide what it sounds like. Okay, so when you're gonna, like on a test, for instance, you're gonna have 4 lessons of different kind of questions, right? And you're gonna have to decide which equation you're going to use, okay, before you can even really write down your knowns and unknowns, right? So you're gonna have to read the question like this one, okay, and then you're gonna have to decide what equation you're using, okay, and then you can do your list of knowns and unknowns and make the substitutions and solve for whatever it is you're looking for. That's it. Okay. So this example, Lisa's parents would like to have $150,000 when they retire in 9 years. How much should they invest right now at an interest rate of 5.75% per annum compounded annually? Okay. So there's lots of different little things going on in here. I can highlight this is important, that's important, that's important, this is important, and that's important. Okay, so I know because I'm in this lesson that I'm going to probably use the present value equation, and that's going to be equal to A. What I'm going to do here, you can choose whichever of the two that you want to do. What I'm going to do is pick the one that's 1 plus I to the power of n. Okay, just for simplicity. Okay. Now, I can do my list of knowns and unknowns. PV is obviously the thing I want to know, right? A is going to be the 150,000 that I want to have at the end of the 9 years. Okay, and then the interest rate we could write as being 5.75%, but remember that has to be in a decimal. And in order to switch from a percentage to a decimal, we have to divide by 100. So that's going to equal 0.0575. And then n is equal to the number of compounding periods. Okay, well, look, we're going to see it's compounded annually. Okay, and they're also, here's the other thing, they're only earning this 5.75% per annum, which means per year. Okay, it's just a fancy way of saying per year, and it's compounded annually. Okay, so they're only earning that 5.75% once per year. Okay, so the number of compounding periods is going to be the 1 time per year that they're getting it times the 9 years that it's in there. Okay, so 9. And now you can just make these substitutions into your equation, and it's going to spit out how much they have to invest now in order to reach $150,000 under these conditions. So 9 years and 5.75% interest. Okay, so let's just go ahead and do that. So PV is going to equal, the A value is 150,000, and that's going to be divided by 1 plus 0.0575 to the power of 9. Okay, and so PV is going to equal 150. 1.0575 to the power of 9. Okay, now what you're going to do is you're going to jump over to your calculator here, and what you can do is go, we could put it in brackets, 1.0575, okay, close the bracket if that works or it does anything, and then we're going to go to the exponent. I need to find the exponent on here. It's the first time using this. Xn, right, which is the same as the iPhone, to the power of 9 equals 1.65. So again, it's 150,000 divided by 1.654. We'll put an extra digit there. Okay, and so just to illustrate this here, the work from this turned into this number, and then I just do the 150,000 divided by 1.654. Oops. Okay, so therefore, Lisa's parents $90,689.23 at this present time in order to end up with $150,000 in 9 years. Okay, so it's a lot of money. Okay, but you can see, like, you figure 90,000. If you took 90,000 multiplied by 2, you'd be at 150,000 or 180,000. Sorry, right? And so you're getting quite a lot of money here, just for investing the money, right? It's not bad. Okay, and it's a lot of money to come up with up front, but at the end of the day, you're not doing too bad, right?